Okay, guys, in this video, what we're going to do is basically continue on with where we left off in the last video by taking all of that super cool lighting information that we gave you guys
and putting it to
practical use.
Exactly.
That's right. We're going to create a simple light class, the same way we created that texture class earlier. And this light class is going to allow us to easily add lights into our scene as well as adjust the parameters of the lights themselves.
Exactly.
So we're going to pick up with the same application we've kind of been slowly developing.
Yeah.
Where we branched off and just used SDL to continue with the rotating cube thing. And to be honest with you, all of the changes that we've made apply to, well, all of the different window interfaces, almost 100%.
Right.
And so you guys are more than welcome to use whatever Windows interface you like, but we're just going to continue working with this SDL one because it's very clear.
Right.
And so anyways, go ahead and run it real quick.
Yeah,
just as a reminder. So we left off in the textures video.
Notice no shading.
That's right, with a cube that had our little 3D buzz texture applied. Some of them were backwards, some of them were, scaling really large.
Tiled.
That's the bottom side.
Right.
And the top is, I was talking about the bottom.
Oh, okay.
See, ta-da, it still is. And then the top is tiled. And so now all we want to do is, after getting this light class created,
right, we
want to create a light in our scene just so that by the end of this
video, we'll put a spotlight on it.
Yeah, we'll see some illumination taking place.
Yeah.
So everything won't be bright. So let's go and get started.
All right, so let's
add a header file.
Header file.
A header file.
So let's create a new item. We'll just call this light.h.
Sounds good. And we'll
our
go ahead
source file.
Yeah.
So I'll create this loot.
Our light.cpp. Now, let's jump back over to the header file, and let's go ahead and begin with our if not define.
Yeah. If you've watched any of the other videos, this should now be very clear. You'll never forget to do this.
No.
And we'll throw in our light class real quick to find it out.
And we can go ahead and do this real quick. Okay. We're going to be using OpenGL stuff in here.
Obviously. Right, so let's go in here and just
let's copy all of that.
Yeah. Just put that up here. All right, sweet. All right, so how are we going to do this? Well, first, I always like to start out with the constructor and destructor, so let's throw this in. But I do want to be able to specify inside the constructor what kind of light I want to create.
Which makes sense.
Yeah. So we'll just call this, and to make it even easier, we'll create an enumeration called light type.
Just so we can specify like spot, point, and directional. Exactly.
So we'll just call this a light spot, light point, and light directional.
And remember, light spot and light point, same thing. It really comes down to how you define that cutoff.
Yeah. And we'll define that in the constructor.
That's right.
Oh, well, actually, we'll be calling another function inside of our constructor, but basically,
in the constructor.
Yeah, exactly. So our light type, we'll pass it light type.
Yeah.
And then we have our destructor. And there we have it. And another thing we want to do is maintain a list of available lights. Because remember, we want to check with the OpenGL engine and say how many lights can we use.
Right.
And then we're going to create a list of lights that we can have. And anytime we create an instance, take that light, and when we destruct, in our destructor, we say, all right, put that light back to available use.
Exactly.
Does that make sense? Okay. So inside of here, what we're going to do is maintain a static list of all vectors. And remember, we have our, let me just type this in here, GL light 0, that's one constant,
that's
GL
right.
light 1, etc.
Not only that, but now that we're using vector, we may want to include vector.
Right, we'll include, let me just type this out real quick. Available lights, and I also want to maintain a list of all pointers as well. So let's just create a static vector light pointer, because remember, we need to update every light, change its position and spot direction on every pass. So we'll maintain a list of lights so we can simply loop through this without having to know the name of every single class or instance that we create. So let's do our include vector, and say using std vector. And then if we move back down to here, another thing that I want to create is, a static variable that just holds the number of lights that we can create.
Okay.
So num lights. And we'll use glget to actually get that information. And some private variables that we need. So if I go down to here, I forgot to define this as public, so let me just go ahead and throw that in here. And then if I move down, create our private section. And of course we're going to need our light position. So let's create a GL float. And we'll just call this position. And it's going to have 4 attributes. Remember, we said we had X, Y, Z, and then the final 4th component is going to say what kind of light it is.
Yeah.
Exactly. And we're going to hide this from the user, so they never actually have to set the 4th component. We set it for them. And then let's just copy and paste this, because we have quite a few of the same kind. And we have our diffuse, which has RGB and alpha, our ambient, RGB and alpha, specularity, same thing. And we also have a spot direction, which specifies which direction the spotlight's going to shoot in. And
a couple more things, cutoff and exponent.
Right, for our spotlight. So the cutoff and our exponent also for our spotlight. And we're also going to define a visibility to set what kind of visibility is. And we're also going to store the light type. Now remember, light type is going to be stored in the fourth component of position, but light type is going to store it using this enum. Mm-hmm. So if we actually want to get it and see what kind we have, we can check with that. And let's see. We'll also throw in our light num, and basically this holds GL light, GL underscore light 0, GL underscore light 1, etc., etc. Just
simplifying things is all you're really doing.
Yeah, that's all I'm just providing an interface, an object-oriented interface into OpenGL. So with those simple ones, let me go ahead and define the constructor, then come back and add in the rest. I'm going to need to define these static variables, so let me copy these guys, come over into here and just paste them in, and then include our light.h real
Obviously.
quick. Light.h, I can do it. And let me just finish defining these guys. So we have our light, num lights, and we'll initialize this to 0. Again, we're going to initialize this in just a second. And then let me just take that. And we have our light, 0. And like so. So our main constructor, how's this going to work? Well, let's just do our light constructor. And no, light, thank you. And this is going to be our light type, or just type or whatever. Don't forget our underscore.
Mm-hmm.
And let's see, let's have our inside of our constructor. The first thing we want to do is populate this current instance into our lights variable. So we can simply do a lights.pushback this. Very, very simple. Then we want to check to see, remember, available lights holds all integers that are available to us.
Right, now the moment we get a light and put it into use, it is no longer available.
Right, and it needs to be removed from that list.
That's right.
So the first thing we need to do is check to see whether or not available lights, there is a light available. So we can say if size is greater than 0, let's just cast this to an integer to prevent any warnings. And inside of here, so there is a light available, let's get the light. So light num, remember that's our private member variable, is going to equal the first available light inside of the light variable. So since it's a vector, we can just say index 0. And now that we've got it, let's remove it from the list. So let's do an available lights, and we'll just erase out the first one. So available lights.begin. So erase it, and then we'll set our visibility to true. So we'll call our I'm going to create a visible function. Mm-hmm. Actually, let me just throw that in real quick over here. Just pass our void visible and pass it a bool value.
And default it to true.
Let me default it to true. Thank you. And I'll just copy this, come back over to here. Just throw this in here so I don't forget. Light visible. Let me just come over to here and just say visible equals. Actually, let me implement this in just 1 second because I want to.
That's fair. Yeah. Go ahead and finish off the line.
Yeah. So we have here, and then we're going to also have another member function called setLightType. Again, I'm just calling my own member functions to kind of simplify this whole thing. Pass it the type that was passed to us. And we have our setAmbient, which sets our ambient color. SetDiffuse. Again, all of these functions will be defined in just a moment. And setSpecular. I'm just setting some default values so that we have something that's fairly logical to work with at the very beginning. So our specular color is going to be white, diffuse color is going to be white, and our ambient color is going to be black. And then I'll call it update light, which updates the position. And that's it. So what if we don't have a light available? Simply set our light num equal to 0. Just initialize it to some value and set the visibility to false. Again, it's probably already not true, but just in case, go ahead and set it to false.
Sure.
All right, which basically is going to initialize our own visibility attribute. That's the main thing it's going to be doing. Since lightnum doesn't exist, if you call GL light FV with lightnum equal to 0, you're not going to do anything. So that's basically our constructor. What about our deconstructor? This is really simple. We just do again, once the light, we kill ourselves, we need to put the light back in to available lights. So if the light num does not equal 0, remember if light num is 0, that means we never even created the light.
Right.
So we simply do available lights dot push back. So push it back on. So now that light is now available again. And then we also need to remove ourselves from the lights list. So simply loop through the list with a vector light pointer and then create an iterator that loops through the list. Iterator, thank you. IT with lights.begin, and then IT does not equal lights.end, IT++.
You guys have seen this over and over.
Yes, you must understand how this works. Because it's not that difficult, so. And then just lights.erase, IT. And so there you have it. So now let's go back into our header file and start setting up all these accessory functions. Because again, this is just an object-oriented way that we can interface with OpenGL. So what kind of things do we have? We have our set diffuse. So set diffuse, as you saw in the constructor. And we're going to pass a red, a green, and a blue, and an alpha. And let's just copy and paste this because it's the same for ambient and diffuse, ambient and specular. Yeah. And let's see, we also want to be able to set our light type, as we saw in the constructor as well. So we have a void set light type, and we'll pass it light type. And we also need to set our position. Mm-hmm. So we have our void set position, and float x, float y, and float z. And our void set spot direction. And this is going to be also float x, float y, and float z.
Now set cutoff.
Yeah, we're just kind of setting all the things for the spotlight here. I can actually define this. Set spotlight specific member functions. There. Just to make it clear to everyone. Then we have our set cutoff, which is just, we need to pass it a value. But which is in degrees. And then we have our void set exponent, as we talked about before, allows us to set how fast our spotlight ends or fades away. And then we have our set attenuation, which we talked in depth actually in the last lesson. Set attenuation. And we have our constant, our linear, and our quadratic. Typically you'd have to have 3 separate calls if you're using OpenGL directly. This allows us to use one function call to set all 3. Which is very cool. Mm-hmm. Then we also have our get light num, just some accessory functions now. So pass this as void. And we have our void update light, which is going to simply update the positions. So with that, let's go ahead and start implementing these guys over in our light.cpp. So let me just copy all of these.
Copy. Whoa, not quite that big.
Not quite that big. Copy all of these. Cover over in here and just paste these in. Alright, and then let's copy the light : scoping it in, and get rid of all a lot of typing here, but really very, very simple things, because light handling inside of OpenGL is really simple anyway, so this is just an even simpler way to access the OpenGL functions. So how do we do this? Well, we need to first set up our diffuse channels, because remember, if we go back into our light.h, we have all these things set up. Mm-hmm. So we need to go ahead and set these with what's passed to us. So what we're going to do is diffuse, and we're going to set this to our R component. And diffuse 1 is going to be our G component, and diffuse 2 is going to be our B component, and then finally our diffuse 3 is going to be our alpha component.
Right.
And then what we need to do is actually call the GL light FV, right? Which we talked about in the last lesson.
Because basically we're using the array here.
Right. Notice at the very end here we have a pointer.
Right.
And then we pass our light num, our GL diffuse, because we're setting diffuse here, and then simply pass diffuse in.
What value, which is diffuse. Excellent.
And then we do the same for our ambient and specular. Let me just block these in with our, make life a little bit easier, because we need it for all of these anyway.
Sure.
And for this guy, this guy, and this guy.
Now you can go up and just pretty much copy diffuse, paste it down in ambient,
and life will be good.
Make a couple quick changes.
Yeah. All right, so for our ambient, simply replace it with ambient, and done. Same with specular. Change this to specular, and copy and paste this in. And of course, we need to change this. Yeah, I caught it before you did. So
all
we
right.
have our
Since you caught it before me, I'll go ahead and add the other one. Go back up and change the last argument as well. Well, that one would be ambient, far right, last argument.
Oh, yeah. Oh, he got me there. All right.
Specular.
And that will be specular.
That's better.
Yes, much better. So let's go back into our header file real quick. We have to set our light type, and we also have to, when we do our set light type, we have to change the last value of our position.
That's right.
So if we come back into here, light type is our member function variable. So let's just call this type so that we can actually do light type equals type. And then all we need to do is see if type, or well, let's just use light type to be consistent. Makes a little bit more sense. Our enum value of spot. Then for a spotlight, we know that we simply set the last position, which is 3. Remember, we're 0 based here.
That's right.
And this is going to be equal to 1.0f.
That's right.
And then here, our light type, if this equals light point.
Still set to value of 1.
This is still going to be a value of 1. So we set position 3 equal to 1.0f. But in this case, it's a point light. So light should emit from every direction.
So we can basically set the cutoff up to a good 180.
Yep. So 180. I can do it. 180. And finally we have, let me just copy this. My hands are getting tired. So light directional. And for this one, very simple. Simply set the last component equal to 0.0f, and we're done. Finally, we need to update our light because we just updated the position. So we need to update that with our GL light FV, which is going to be done inside of our thing. So set position. Same thing as up here. So let me just copy this. Pretty much the same. A little bit different because we only have 3 components that we're going to be setting directly. So we have our position, and this is going to be X, Y, and Z, and this is GL position. Right?
Yep, and then change specular to position. Beautiful.
Positions. Position. All right. Set spot direction, almost exactly the same as our set position, so let's just copy and paste this.
Set spot direction.
This is all pretty easy, isn't it?
Yeah, it's really straightforward.
Just a lot of copying and pasting, really. And this should be spot direction.
Very good.
And for our set cutoff value, same general idea, but we first need to set our local one that we have here. So cutoff equals value, and then go ahead and call our GL light FV, and simply, not light FV.
No,
F
this is just F
case.
because it's a scalar value.
Right. This is going to be GL spot cutoff.
So we're just specifying our cone angle here.
Right. And that looks good. And then our exponent, same exact idea. But this is going to be spot exponent. And this is going to be exponent, if I remember right. Is that how I said it in the... Yep, that's right. This is in the header file. I want to make sure it's spelled right.
Well, if you don't ever set it, then...
Yeah, that's right. So, in our set attenuation, let's go ahead and do our GL light FV, just F, excuse me.
That's right. And we're just going to set those 3 things that we showed you guys in the last video. The constant attenuation, linear attenuation, and quadratic. This is what Joel was talking about a minute ago when he said that we can do all 3 of these at the same time.
Right. So we've set constant, then we're going to just copy and paste this. And we have our linear and quadratic, which I guarantee you I'm about to spell wrong.
Oh, I spell it wrong every time. I spelled it wrong in the last video, which was funny.
Did you really?
I think I did.
Wow. Quadratic, attenuation. This one's going to be linear. This one's going to be quadratic.
Simple.
And, of course, we're not storing this simply because we don't need to know it for our own selves. So.
Right.
And in our get light num, this is really hard. Return light num.
Okay, I don't understand.
Okay.
Just kidding.
All right, I'm going to go into VTM mode here.
Wait a minute, we're doing a VTM.
Oh, that's right. So in our update light, we need to update the position. So our GL position needs to be updated with our position. And our GL spot direction. Spot direction needs to be spot direction.
Obviously, these are very important. I mean, every time you go to move your camera around, which, oh yeah, there's not really a camera.
Right.
So you're really kind of rotating your whole scene.
Yep.
Oh yeah, to simulate that we must move our light and all.
Yes, exactly.
That'll mess with your mind.
No kidding.
But that's a very important concept to make sure you understand. Okay, it's looking good. I think you're about there.
Almost there.
Yeah.
I need to set my visibility. So visible, I promised I'd do this, so here it is. So if visible equals true, or just if visible.
Here comes the big GL enable.
And light num.
Turn it on.
Turn on that light. Whoa. Turn on that light.
That was scary.
Otherwise, GL disable the current light.
That's right.
And a few more things I actually need to throw in here. If you remember, we have all of these different things, the cutoff, and these are not going to be initialized to any particular value. So let's go ahead and come back over to here and just add the rest of them in. There's only a few. We have our set position, set diffuse, set ambient, set specularity, etc. And it would be just a good idea. Well, we already have set ambient and diffuse, but we need our set position. So we can simply set this to 0, 0, 0.
Sure.
Internally, the light already sets this to 0, 0. But what if we deleted a light and we're using the same light as before?
Right.
Because we only have 8 to work with, so at some point we're going to overlap. So we want to reset it. And let's see, what else do we have? We have our set cutoff and set exponent. So let's do our set cutoff. And we'll just set that to 45 degrees by default. And set exponent. And we'll just set that to, say, 12 by default.
Cool.
And these are just values that I'm kind of just
that
guessing.
Sounds good to begin with.
That sounds good to begin with. And finally, our spot direction. And then I think that's it. And we'll set that to 0, maybe 1, 0. So the light's pointing up.
Okay. Well, how about -1?
Okay, -1.
Wouldn't that make more sense?
Yeah, so it's shining down. Yeah,
right.
That's a good idea. Not many spotlights shining up. But anyway, yeah.
Cool.
So I think that should be everything. If we come back over into our SDL demo, let's go ahead and include this just so it gets called. And let's go ahead and do a compile and see how many errors I got.
Just to start working through our little errors.
Yeah. You're pretty confident there's a lot of errors?
No. Well, maybe.
Specular is undefined. Did I not define specular, or did I spell it wrong? I didn't define it. Specularity. Okay, specular. Fixed. All right, 2 more. Cannot convert. GL float. Okay. I light FV. Thank you very much.
And that's a very easy mistake to make right there.
Very, very simple.
You just got to keep in mind, like position and direction, obviously we're dealing with, multiple numbers here and defining that. So.
Right. So just make sure that's a V.
That's right.
So it compiles.
I'm so impressed.
Oh, yeah.
No, that's really good.
So now we have everything working. Now let's go ahead and implement into our SDL demo so that our queue can be illuminated with a light. So a few things we need to do. First of all, let's create a light.
Right.
We'll just call this our main light. And we'll initialize this to null.
Sounds good. Just like we did. This is, you notice a little texture thing right underneath that. This is
almost exactly the same.
Yeah, it's almost exactly the same.
I mean, we can come right down to our GL enable for our GL texture and put in our GL lighting.
Turn on lighting.
Hard. And then here we can come into our main light and create a new light. And we'll create a spotlight. Oh, no, light spot. Forgot how I define my own stuff. And how do we want to define this? Why don't you tell me?
Okay, well, you could do a specular. I'd say let's do diffuse. I'm sorry. Let's go ahead and set the diffuse to, I don't know, like 1.2, 0.5. So we're going to give us a nice red tint.
All right.
And, of course, the alpha at 1.
Yeah.
And then let's go ahead.
Just some test values that we can use.
The default spot direction's good.
Okay.
So we don't have to do anything there.
Okay.
Let's go ahead and set a position, though.
All right.
So let's see. Camera move back, so I'm going to move 5 units up and Y. Okay, so 0, 5, 0.
All right, 0, 5, 0. So because our cube, I think, is 1 by 1, 1, 1, 1.
Right.
Simply move this 5 units in Y.
That's right, and it's already pointing in the right direction, so that works out. The cutoff's already at 45, and I think that's going to work out nicely for you. So that's pretty much that. Also, don't forget we need to initialize our light, too.
Okay. That's right at the top here, and initialize. Remember, we have, if I just go back real quick.
Absolutely.
To our header. Oh, and I totally forgot to do... did I forget to... Yes, I did.
Did we not put...
Yep, I totally forgot to implement one function. You'll notice here that we have our available lights, but I never initialized this available lights to include all of the functions that we need. Well, all the variables that we need. So let's create a static light function that allows us to initialize this static variable. So right here, let's go ahead and do our void, and we'll just call this function initialize, and don't need to pass it anything. Its only job is to really loop through everything and populate our available lights function, variable, excuse me.
Exactly.
So let's create this as a static void. copy this, come back over into here, and just at the very top here, do our initialize.
This is where we'll use the nice GL get integer v.
Get integer v.
And then GL max lights. This is where we're going to find out how many lights do we have.
Right, and again, it's almost always 8, but...
And put it into num lights, just like we said earlier.
Right, and again, this is a static variable, so it's going to stay the same for every single class.
Every single object.
Yep, every single object, yeah. And then let's loop through all of these lights. So int equals 0, I is less than num lights,
and
I
push
plus
them
plus.
onto available lights.
Yep, so available lights. I can do this, push back. And then just pass it GL. Remember, we have our GL underscore light 0, and we need to plus I to that. And basically that means for our first pass, we're simply going to pass on GL light 0, GL light 1, GL light 2, etc., etc. And that's it. That's all there is to it. So,
cool. So now, again, we need to go ahead and initialize that right off the bat back over in the demo CPP file.
Yeah, so like right here.
Because we need to get our lights. What do we have available to grab from to get going in the scene? Exactly.
Otherwise, it would just go into light.cpp. When we create a new light, it's going to say available light.size is 0. So it's not going to do anything. So once we have that, let's see. We've created, if you kind of remember back to our last lesson, we said you need to enable lighting. We've got that. We need to enable a particular light. We got that inside of our class.
Here comes a big one we need.
Now we need to add into our normals.
That's right. We must have normals for all of our polygons. And remember, that was really easy to do. All we need to do is do the GL normal. Right. And we'll just use 3F.
Yeah, GL normal. 3F.
And since this is a nice, neat cube, all we need to do is, just set the X, the Y, and the Z. Very easy.
This is a top face. Bottom face is going to be down negative Y. Front face is going to be positive Z, if I remember that right. Back face is going to be negative Z. And let's see, left face is going to be positive
Y. I mean X. I'm sorry, just kidding. Are you doing left? Yeah, and then right face is going to be a negative X.
Right.
So negative 1.
Sweet.
You know what I mean?
Yes, I do.
It's too much.
So I think that's everything
now,
we need.
Now, are we updating our light?
Yes, and this is where it's really important, because notice we can rotate our cube, and we have all this rotation stuff going on.
That's right.
So we need to loop through all of our lights, but this is going to be very easy, because if you look over here, we have all our lights being stored.
That's right.
So all we need to do...
just a quick loop, and then tell each light to update.
Right, so int I equals 0, I is less than, and we just go light, and then go to lights.size.
We'll go ahead and cast that over to an integer.
I don't like warnings. So just loop through all of these and just say light,
and then each light within the array.
I, and then just update light.
That's right.
And that's all there is to it.
Cool.
So if everything worked properly, which it should.
It should, but there's a couple little things that need to be cleaned up.
I totally forgot to scope it up.
No, that should actually go all the way through.
Yeah,
and it does.
Sweet. All right, so let's go ahead and run this and see what we get.
Ooh.
So look at that. We do get lighting. Notice the bottom face is almost completely black, and the top face is illuminated with this reddish light. Now,
just cool. Let's show them we can turn the intensity of that up.
Yeah, let's make it white just to show how that works.
First of all, we can just simply. All right.
Let me make it white.
Okay, that's fine.
And then we can show maybe other colors. So with full intensity, what you get is this right here.
Let's make it brighter now while leaving it white.
Okay. So what do you want?
Turn some values up a little bit higher, like go with 2, 2, and 2.
Sure.
Yeah. Do-do-do-do-do-do. Ta-da!
So we get this really nice brightness.
Yeah, that's all. I was just wanting to show that we can control that by turning that up.
Yep, we can turn up the intensity.
Right. Now, we don't have a lot of detail here in our cube.
No, we don't.
So it's not like we have a really cool scene to show you guys some complex lighting scenario.
Yeah.
But in the next video, we're going to set up a nifty little demonstration.
Yep. It's kind of to show off the whole idea of tessellating, if you will, a surface so that it has more detail. So we're just going to bring in a simple plane, tessellate it a lot.
That's right.
And then be able to show a spotlight on it and actually see the cone.
And we're going to...
along with the attenuation.
And we're going to go as far as animated as well, just so you can see the lights actually...
moving around.
Yeah. So anyways, that's pretty much it. So this new light.cpp and light.h file, very important files. Keep track of them just as you're doing with the texture.h and cpp file.
Yeah.
So that you can add these into your own project so that you have quick and easy support for lights and textures now.
Right, and what I often do is put all of these files, the texture.h, the light.h, etc., into one common directory and simply have all of my projects point to that directory so I can use them really easily.
That's right. So with that, that is going to wrap up this video. Thanks a lot, everyone.